Hello, everybody. I'm Stefan, and I want to talk about the current state of web technology. And before I'm going to start here, I want to make sure is that I'm a big JavaScript fan, but I will do a 38 minutes rant in the 38 minutes rant will start now. So let's just dive right in. Did web development lose the right direction? So as I already spoiled, this is a talk about general best practices. And just so that you know who is speaking to here right now, I'm Stefan. Hey, I do front-end development in JavaScript for roughly a decade now. I work for a company that is called Contentful. So if you're doing a front-end or JavaScript development and you're looking for a content management system that is API first to build your blog, your company website or something, you can check that one out. But I'm not here to talk about Contentful. I'm here to talk about the state of web development today and of the state of web development basically 10 years ago, which is when I was starting doing all these kind of nerdy things. So I started web development with an internship at an e-commerce company here in Berlin, Germany. And I was studying computer science and I was confronted with this technology stack here, MySQL, Apache, PHP. And honestly, I was already so overwhelmed by what all these people were doing there. People were opening up their terminals, they were doing server configs and building PHP applications, and I was already heavily intimidated by that. But I got used to that at a certain point, and then what we had in this application at the time was Prototype and jQuery. So for the people that do front-end development long enough, you might know that Prototype and jQuery are basically the same, solving the same problem, but we had both because more is always better. It was a Magento shop, and then slowly but surely we moved more things into the front-end layer using Backbone.js, which was one of these first MVVM frameworks, if someone remembers these. And in the same time, because we had more things running in the client, new best practices started to appear. What you see here is YSlow, which was a collection of front-end best practices to build a very fast website. And as I now was slowly but surely becoming a web developer, of course I had to start blogging, or at least try to start blogging. So what you see is my first blog. It was built with Ruby and with Jekyll. I had no clue what I was doing. We made it in total to a few posts, and then we stopped blogging. I think a lot of people have that problem. And then something interesting happened. Grunt and Gulp actually entered the stage, and front-end development changed with these two tools, in my opinion. Because now front-end development became more than just concatenating and minifying files. Now it became a complete dependency tree, a complexity moved into the build pipelines. I feel like things changed with these two tools dramatically. And then I did Angular and a little bit of Vue and React. And really the only thing that I want to tell you here is I'm the absolute JavaScript fanboy. I love technology and I love writing JavaScript. So as it is when you're into JavaScript, I was running my own private blog for 3 years in one of these new JavaScript frameworks that runs JavaScript on the client side and the server side. And overall, I was fairly happy with it. And I made it to blog a little bit more than with my first Ruby approach. And when you care about qualitative, high-quality websites, you might know about this tool here. What you see here is Lighthouse. So Lighthouse is basically included in the Chrome DevTools, and it gives you a hint about how good your website is built. And you see there that I had at the time a pretty decent score. I had a 90 in performance, I had a 100 in accessibility. There was something off with best practices, and SEO was 100. And when you care about web performance, you might also know this website. So what you see there is webpagetest.org. What you can do there is that you can paste the URL, and it will give you some synthetic metrics about your website and how fast it is loaded under certain conditions. So you see there that I had at the time a speed index of roughly a second. In case you're not familiar with the speed index gives you an idea on how fast the majority of a website is visible. So this basically meant that my website was pretty much there on a cable connection after 1 second. And even on a 3G connection, 4 seconds is not too bad to render the majority of the website. So when you monitor your scores in Lighthouse, you can really take this rule. When you're above 90, you're usually in the top 5% of performant websites of this world. And of course, due to the technology choice that I made with this cutting-edge JavaScript framework, there were a lot of best practices included in my own little tiny website. I was using HTTP2 to get down the assets quickly. Everything was compressed and minified. I had a module, no module bridge to not ship polyfills to evergreen browsers. I had special font loading in there, a preloading strategy, and of course, everything was code splitted, because this is what we do these days as JavaScript developers. And then at some point, this website was trending on Hacker News. So what you see here is a random website from Italy. It looks fancy, and it's probably a little bit too outdated for 2020, but it is fast. And the funny part is that it's also still updated as of today. And when you look under the hood of this website, you will find out there are a lot of GIFs. And the HTML, of course, is not following best practices. But what happens when I open this website in Lighthouse? This website has a full 100 performance score in Lighthouse. And even the Jekyll blog that I built without knowing much about web development was outperforming my cutting edge website that I was building and tweaking on the weekend. And I spent hours over hours optimizing the whole thing. So I couldn't believe this. So I went back to web page test, and when you go there to /video, you can paste in 3 URLs, and what it will give you is a comparison video and how fast the website loads. And indeed, you see there that my cutting edge website was outperformed by these 2 websites. And this frustrated me. And how can that be? You could now say, well, Stefan, you just messed it up. But the question that I want to bring up here in the next 30 minutes is, how can it be so easy to mess up? So when we look under the hood of these 3 websites, let's find out why my website is performing worse than the others. So when we have a look at the overall page rate, even though that is a little bit comparing apples and oranges, but the overall page rate of my page is way higher. I'm shipping almost a megabyte uncompressed, so before gzipping, of resources. My index HTML is huge. 100K for gzipped. Gzipped index HTML is, well, questionable. CSS resources are more or less the same. The number of JavaScript resources is substantially higher on my site. Image resources don't really matter in here. And the mix here of these kind of things shows that my speed index is lower and my Lighthouse score is lower too. So how is the performance Lighthouse score calculated these days? So when you have a look under the hood, you see there that it is basically a mix of 6 metrics, and it's calculated like this. So it's including the first contentful paint, which means that there's something meaningful appearing on the screen, and when this is, then it's considering time to interactive, which means that the browser is done with parsing and executing all the JavaScript. Then we have the speed index. I already covered that. That's the time until the majority of the website is visible. Then we have the largest contentful paint, which is like kind of coming chunks when these come in. The total blocking time, which is like how long is the browser actually blocked executing JavaScript. And then we have the cumulative layout shift, which gives you, hey, this page is jumpy while it's loading, or it is not. And when you look at these numbers, you see that these 2 are directly related to JavaScript execution because browsers today are single-threaded. And when the browser is busy doing JavaScript, executing JavaScript, basically nothing else can happen, which frustrates the user in the long run. So if you want to learn more about the speed index and not the speed index, the Lighthouse performance score, you can check out these 2 resources. Carolina wrote a nice article about how it's calculated. And if you want to learn about what it actually takes to improve, to maybe get a 90 or 91 in Lighthouse, you can check out this calculator by Paul Irish. So I really want to point out that even though we're doing maybe server-side rendering, the state of showing our users some UI that is not working is extremely frustrating for everybody. People don't understand that because they see a button that it maybe is not working because JavaScript has to be downloaded, parsed, and executed. This will directly affect your conversion rates depending on what you're building. And when you have a look at device execution times across the board. Not everybody has a latest Pixel 4 and iPhone. What you see there is that Tim Kadlik shared some resources on how long it actually takes for devices across the board to execute websites built with a certain framework. And you see there that statistically, websites that are built with React can take up to 20 seconds execution time of the shipped JavaScript bundle. And I really want to question you, will you wait 20 seconds for a button to become active and responsive? I'm really not sure about that. But for some people, this is really the normal status of the web today. And Netflix had this little experiment. What they did is they had a sign-up form, which was built with client-side React. And really, when you think about this, a sign-up form is 100% conversion. The only thing that you want people to do on a sign-up form is to sign up, right? And what they found is that by dropping client-side React with a little bit of vanilla JavaScript, is that they could improve the time to interactive by 50%. And when you think about a sign-up form, what do you need? You probably need a submit handler and some validations, and that's it. It's a username, a name, maybe a password. There's not much logic there. Do you need a framework to do that? When you think about the overall page rate, it's always important to consider that 150 kilobyte of an image is nothing compared to 150 kilobytes of gzip JavaScript. Because JavaScript has to be downloaded, executed, and parsed. Page rate is not equal page rate. So when we come back to the comparison of my cutting-edge JavaScript site with the other two websites, what was included in my 340 kilobyte index file? And as I hang out on Twitter quite a lot, right? I tweet a lot. I got the same question in public. What are you doing with your website that you need 300 kilobytes of gzip HTML? And what I did is basically I answered that I was following all the best practices, that it's using HTTP2, and that this is basically how we do front end today. And that it's still a good, very good website because it's still better than the rest of the internet. So basically what I said, it's great because it's fast and it's still lighter than the rest. But what I actually did is that I was arguing myself into or out of this discussion because I was really digging the tech stack. And I think it's still a beautiful and very nicely done tech stack. So what was actually in there in this 300K index file? And the main reason why this page was so heavy is that there was a data block inside of the HTML, giving information on what was used to render this HTML. In case you're not familiar with isomorphic or universal JavaScript app, you have templates that run on the server side, and then you can have the same code running on the client, but then the client-side JavaScript needs to know what data was used to render the HTML. And what I decided to do was to preload and inline 22 articles on this index page because I wanted to have a very snappy transition from A to B. But I didn't consider that the average session length of my website was 1.17 pages. People are not navigating that much. And I decided to inline 22 articles for better performance. And now I want to question the choices that I made in the past. And when you're following the web dev on the front-end trends these days, what you will hear very often is that making a very fast website is extremely hard. But I want to question that a little bit. And I want to ask, is it really that hard? Bill Uxworth from Netlify is one of these Jamstack evangelists proposing or trying everybody to move into the static HTML parts again. And he's basically saying that he's building a lot of fast websites, and people ask him how he can make these websites so fast. And his number one answer here is just like that he's not adding anything that is making the website slow. He said that the work was usually done before you actually typed a web address inside of the URL bar. And I was a little bit skeptical about this statement when I read it the first time. So I did a side project. So what you see here is tiny-helpers.dev. And I built it with 11t. 11t is one of these fancy new static site generators. And first of all, it's a little bit faster than it was out there. And it's very, very pure. It is not adding JavaScript where it's not needed. You have to really configure things that you want to do. And to follow Phil's statement, it's not adding anything that makes the website slow. And after building the site, I went into the Google tools and I found that this was a 100 performant website, at least to Google Chrome Lighthouse. And Zach Lead, who's maintaining 11p, is actually very, very proud of it. So what he's doing here, he's maintaining the 11p performance leaderboard. And you see that the median Lighthouse score is a solid, easy 100. So is it really that hard to build very fast performing websites? A few years ago, I was giving this talk in Oslo, and what I said on stage in front of a couple of hundred people was that every website is a web app and every web app is a website. And oh boy, I could not disagree more with past me, because I want to ask you where the benefit for our users is with such overhead. So I briefly touched already universal JavaScript apps, so let's dive into this a little bit more. So when I started building for the web, this was basically how a template from HTML5 boilerplate looked like. We had two JS bundles, something for vendors and something for our main JavaScript. We had a style sheet and we had a hello world. Now over the time frame of 10 years, this basically changed to something like this, that we load and code split several bundles. And we have this inline data block that I already mentioned, also sitting somewhere usually in the HTML, or it is fetched. The beauty of this architecture is that the same code runs on the server and on the client. And I'm extremely excited about this because I think it's beautiful. But the same problem is that the same content is in your HTML and in your JavaScript. So for example, when you have these architectures, you have always be careful to split your templates properly, to always consider that the things that you add to your application will have a performance impact because you're shipping more and more and more. And when I just do HTML on the server side, my templates doesn't have to be super clean. It's just HTML at the end. So the advantage of you ship the same code in the client on the server also can become a disadvantage because you're shipping the same thing on both ends. And I really want to question if this is the best way for our users. What a few people say about this architecture of shipping HTML and then enhancing it with the same thing is that this architecture basically offers doors to progressive enhancement. And in case you're not familiar with the idea of progressive enhancement, the idea is that you ship some base functionality, and everybody goes with the stairs example, so let me ship with this one too. So you have some stairs, this is usually HTML, and then you enhance it with some JavaScript most likely, and then stairs become an escalator. If the enhancement fails then, the whole thing should still work, because stairs are stairs, right? At least in theory. But when you're walking around in this world, how often do you see something like this? I live in Berlin in Germany. Maybe that's a Berlin thing, but I see broken stairs all the time. But let me show you one example of progressive enhancement in action. So 7 years ago, I was building this website, which was called Perf-Tooling Today. It was another resource collection. And what you can do here is that you can type in something and you can find some resources. And basically, this is progressive enhancement in the purest form here. So what you see here is a website. You can interact with the input field and it's updating the search results with JavaScript. It's updating the URL so you can do a refresh and get the same result as you have updated. And even if JavaScript fails, you can make an old school HTTP form submit and the whole thing still works. The chance that this breaks because of some JavaScript issue or another is very, very low. Because you have to consider that JavaScript will fail at some point, or any resource will fail at some point, because you have this big question mark in the middle, which is the network layer. And when you're shipping on a massive scale, for example, like BuzzFeed, you will find out that, well, it's not that easy. Something will break eventually. And all your users are non-JavaScript users while they are downloading your JavaScript. JavaScript applications have to be downloaded, executed, and parsed. This just takes time. And it's not only me that builds progressively enhanced websites. So for example, when you go to GitHub, I'm on GitHub every day. I'm very happy with the experience there. As an example, when you want to make a comment on github.com, the endpoint there, the issue underscore comments endpoint handles form submits and AJAX submits. So in case the JavaScript on top of the whole thing breaks or is not loaded, this still works. And even on top of this, there are some 5 old school HTML links. And I'm very happy with GitHub's experience. Because in my opinion, a good site should just work. So when we think about the applications and websites that are built today, what's the enhancement in the wild today? How can we really enhance websites? And I'm going for React here in the next few slides, and I have nothing particularly against React, but you have to pick one example here. So let's have a look at the react.js.org documentation. And you see here a video that I'm loading it on a fast 3G connection. And you see there when I'm navigating around, the navigation feels still fairly snappy. I think this is a fairly good experience. So let me just show you how it looks like when you block JavaScript in your developer tools. So you see that it loads more or less the same, but the navigation feels also fairly snappy. So I would argue that the experiences here of these two websites is pretty much the same. But when you look under the hood, how much data is actually loaded, you see that there's a big difference. On initial rate, all the compressed resources on react.js.org, when I checked this, were roughly 400 kilobytes, whereas it's only roughly, 1/8 of the whole thing without JavaScript. And even after 4 navigations, because there's a lot of preloading going on and such, it's still substantially lighter without JavaScript for shipping the same experience. And this is not, I don't want to point fingers at anyone here because I'm guilty of doing the exact same thing. I shipped a lot of JavaScript without actually providing any benefit to the user. So does this architecture really improve user experience? I'm really not that sure about that anymore. What I am sure about is that in certain cases, it is harming user experience. So what you see here is a screenshot of my phone. This was when I was in the Ukraine. I was at a conference. I should give a talk. So this is still in German, but I will translate that in a moment. So this is the mobile SMS or the SMS that you get when you are in a foreign country. And basically what my data provider is telling me here that Stefan, hold on, you get 6 megabytes for €2, but you have to use that whole data in 24 hours. And I think this is a joke. Right now, think about the fact that I'm landing in a foreign country where I'm not speaking language and all I cared about is maybe going to my hotel and getting a cab. And now when we think about the average website today is that the average website today is roughly 2 megabytes, which means that I can get into serious trouble by booking my cab via a web browser if things are not very optimized. And this is when my user experience is very, very much harmed. And you also have to consider that people pay a different amount of data depending on where they live. Last year, I was, for example, in Canada, and it turns out that people in Canada pretty much care about how heavy websites are because data is very expensive in Canada. So if you want to learn more about what people actually pay for the same access of data as maybe you and me, you can go to whatdoesmysitecost.com and shows you how much people actually earn in certain countries and how expensive the access to data is in these regions of the world. I think that's very interesting information. And what we're doing in 2020 very often is that we ship more data for more or less the same experience. So I want to ask you is that maybe app frameworks are for apps after all. I mean, Facebook is using React to build Facebook. I don't know engineers at Facebook, right? But I think that this is undoubtedly an incredibly complex application. And even when you think about Gmail, I use Gmail every day. I really much like Gmail. I think it's a good piece of software. When you look at how heavy it is, this is 5 megabytes of compressed resources. This is quite something. And this is an application. I'm happy to pay or to download all this because I'm up for that. The funny part about Gmail is that it also provides you a light mode. when you press a button on the footer. And you see a Gmail version that is still shipped to today with 25K, and that just works. If you want to do Gmail emails and maybe have some conversation over email and you're in a spotty and expensive connection, check that one out. That's pretty cool. And maybe these frameworks that everybody's using today are actually not that spread across the web. So last year, the Web Almanac was released. I think it's soon to come up with with the next edition. What a lot of experts did there is that they had a look at websites all over the world, and they did some statistics around these and some statements. So overall, when you look at the most popular websites of today, you see that still 85% of these websites use jQuery. And when you look at the framework adoption across the web, you will see that even though it always feels like everybody's doing React, Vue, Angular, Svelte, or whatever comes tomorrow, it is not the case today. The web is not as cutting edge as it seems, and boring is beautiful and fast. There's another thing, though, that I want to cover about JavaScript applications, which is like when you go with a JavaScript application in the front end, you have a lot of benefits of client-side routing. And I'm already doing quotes here. The number one benefit is that if you do client-side routing, which means that you change the DOM and you update the URL, you are allowed to re-implement an accessible navigation. So what does it actually mean? When you do client-side routing, usually what you do is you place a lot of spinners somewhere. The browser has figured everything out in that regard for you. When someone is using assistive technology, they click a button, they get all the notifications that they need, telling, okay, something's happening. We have this little spinner here. Normal navigation people understand. If you do client-side navigation, well, you have to reinvent a lot of things to provide a good user experience. And speaking about assistive technology, to really fix that, again, for people, for example, that use a screen reader, you have to do two things. And our friends at Gatsby did some research about this and user testing. So first of all, you always have to provide a skip link in your website so that people can navigate properly. And then you need to include an HTML element, which is an area live region, where you then change the inners of this element so that people using, for example, a screen reader noticed, okay, looks like we navigated somewhere else now because I clicked something. You have to fix the behavior that the browser gives you for free usually. And I would love to see beautiful experiences like this. I think these are good reasons for client-side routing, nice transitions from A to B, something that makes me smile while I use websites. Unfortunately, I don't feel like this is what we or I use client-side navigation for. But it is possible. So what you see here is a demo application by Sarah Drasner. She's part of the Vue team. And you see there that this is beautiful, right? Things are moving from A to B. They guide the user. This is where you should look at here right now. I think this is nice. But this is not what we're using client-side navigation for. We just replace everything, place a spinner, and call it a day, and break it on an accessibility scale. Even Ryan Florence, who is the maintainer of React Router, said once that there's a chance that he believes client-side routing on the web is usually not preferred. And this person spent hours, weeks, months working on client-side routing. There are also good examples, though. So, for example, when you look at the Vue.js documentation and you look under the hood, you will find out that it is not using client-side routing. And I want to believe that it is for the reasons that I just mentioned. At the end of the day, a great site should really just work. And I 100% believe that to make a great site, you have to still know the foundation of the web, which is HTML, CSS, and JavaScript. And a great site doesn't have to be built with React, Vue, or Angular. And I think that we should maybe change the conversations that we have every day from, hey, what we should we use to build our next product, our next website, to statements that are like, you should use framework X with server-side rendering, with an offline strategy, because really everything needs a service worker today and has to run in a function running somewhere on the CDN edge node. Maybe the answer should be like all the time in development and programming. It depends. What's your use case? A great site can be built with React, Vue, and Angular, but I think it's more important to discuss the following things. A great site is accessible, fast, and secure, because this is what maybe our users care about. And I would love to get away from the statement that it is just HTML. HTML defines 100 elements. The HTML input element defines 22 types. HTML is still evolving. So for example, did you know that input elements have a enter key hint attribute? With this, you can control how the submit button looks on virtual mobile keyboards. I think that's pretty nice. This is directly impacting user experience. Chris Coyer from CSS Tricks wrote a 4,000-word article about links versus buttons. And at the same time, we find markup like this out there, where people use the wrong practices with good intentions, but maybe HTML is not that easy. And we have websites, for example, like html.dev, which shows just a lot of patterns that we see in the wild that could have done better with a good foundation of HTML. HTML is not easy. And then you look at statistics, for example, what you see here is a statistic from WebAIM, which stands for Web Accessibility in Mind. And they once a year, they have this million projects, which crawls the web, and then they check the website that they crawled for accessibility errors. And you see there that the most of these errors are missing alt text, empty links, missing forms. A lot of these are just related to not great HTML. And when you dive deeper into this data, you will find out that usually websites that use a JavaScript framework perform a little bit worse than the rest. And that is not the developers or the framework's fault. But when you think about this whole thing is, the more complexity you bring into a website, the more things you have to know. And at some point, you cannot know everything. So according to their report, you will see that they crawled a bunch of websites, and they found out that 98% of these websites had detectable WCAG, which stands for Web Content Accessibility Guidelines, detectable WCAG errors, 98%. And at the same time, every now and then we have these kind of statements that some third party was hacked and a lot of websites are mining cryptocurrency. And I think this is surprising because we have a mechanism in the web platform itself, which is content security policy headers, to prevent these kind of things. So what you can do with CSP is that you can nail down what resources should be allowed to be loaded in your website. This is a good safety net to not be the website that mines cryptocurrency without knowing it. And when you have a look at HTTP archive data or data that is publicly available and crawling the web, you will find out that only 6% of the most visited websites of these world use CSP. And we ship more and more and more complex bundles, and in the same time we ship 80% of the bundles we ship have vulnerable JavaScript in there. Overall, I feel like the web loses quality. But hey, I mean, at least developers get more productive. And it all started with Node and NPM, and Grunt and Gulp maybe. But we moved forward now in the last few years. Now we have services like Heroku, Netlify, Vercel, and I'm a front-end developer and it has never been so great. I can now deploy serverless functions like the one you see see in front of you. And with 6 lines of JavaScript, I can build my own APIs. Building a product has never been that easy. There are free, generous services for everything. You can use Google Analytics, Contentful, Firebase, Sentry, Algolia. There's so much stuff. If you want to build something today, you can do that very, very quickly. But in the same time, the hello world from HTML5 boilerplate, maybe 10 years ago, went from 10K of resources to 40K. And I might be okay with that. But at the same time, I feel like the complexity of building for the web just increased so unbelievable much that I want to question the outcome of that. So let me show you this example of tiny helpers again. So it was actually, I talked with Chris Heilmann earlier today. So it was basically Chris who wanted to add a new tool to this resource collection, tinyhelpers.dev. And what I provided was an NPM script to add a JSON file. And to run the command npm run helpers add, you had to download 700 megabytes of Node.js stuff. And he pointed out, hey, what do you need that for? Actually, it's a static site. And when we think about the example that I showed you from Italy here, I bet you that this person only uses a text editor and FTPs the files up somewhere. When I think about my architecture here, what I need is a text editor, I need Node.js, I need NPM installed, I need framework knowledge, and if I have this website sitting on my computer and I want to maybe edit, update it 2 years from now, I can hope that I don't have to update 1 or 100 dependencies. It has never been so easy to build complex applications, but I really want to question how many sites do need to be complex applications? And where are we going with this trend? I was starting my journey with MySQL, PHP, and jQuery. And beginners, people starting building for the web today are confronted with this wall of technology. It's the foundation of HTML, CSS, JavaScript, and we have React, Vue, Angular, Svelte, then we have build tools, then we have hosting. Complexity is king in 2020, and I really want to question, what is that actually for? While I was building this little side project, what I did is that I was using Preact, which is a lightweight React alternative, and I had it running in a function, and I was doing some hydration and universal JavaScript. And at some point, I was just like, no, this is just overhead. The only functionality that I have in this website is a manual mobile hamburger button. And wouldn't it be cool if framework tools could at some point just draw a line and say, well, you don't have enough interactivity in your website. Let's just go with static HTML because this is just lighter and faster. And Jason Miller, who is actually the maintainer of Preact, said, yeah, well, it would be cool if we would reach that point at some point, but we're not there yet. So I dropped the whole framework usage with these 16 lines of JavaScript, and it just works. And I'm not shipping as much things down. I'm very happy about these. So maybe we will have good enough abstractions and tooling in place one day, but today I still feel like that we have to know the fundamentals of the web to create the best user experience. And depending on where you're working, you really have to consider it that if you make a technology choice today, you're basically shaping tomorrow's job market. And your job as a developer should be to build beautiful experiences. But I think this is not true today. I think that my job as a developer today is to decide what tools to use, what frameworks to use, what to prioritize, and then to find out what the best way is to maintain the whole thing. Chris Coyer once shared that he was talking to a front-end developer who was building for the industry 3 years, and at the end didn't know how to build for the web or how to build a website. Because there's just so much things going on, and this is not the fault of the person. We have this wall of technology, and it feels like that the whole term of a front-end developer is slowly but surely becoming obsolete. Because front-end developers today, it feels like we have two camps going on here. We have React, GraphQL, style components, Webpack, JavaScript developers, and we have kind of UX developers that care about accessibility and interaction design and good semantic markup. Maybe it is time for our industry to drop the term front-end developers. And maybe it's more important that we have to admit that our users really don't care about our technical implementations. This is what we're paying to do. We're paid to ship a great user experience. But today it feels a little bit more like we care more about development experience and using the latest and greatest. So at the end of the day, I love shiny tools and I love writing JavaScript, but maybe in the future we should take a step back and consider the right tools for the best user experience. I think this is what I'm going to follow in 2021. So I have 1 minute left according to my timer. So where does it bring me? I had this website running with a universal JavaScript app, and I switched it over to a 11T site, which had the following results. And this is a website with 500 pages roughly. The reduction of I reduced the page weight overall of 64%. So it's just way lighter. The build time on Netlify to generate all the HTML went from 4 minutes to 40 seconds. And I'm still so amazed by this. I don't have a JavaScript pipeline like at all because this is a content site. It has very little interactions. And if I need interaction, I use custom web components. Like, for example, you see the time ago component there that is provided by GitHub. I consider myself now to be one of these anti-JavaScript club members. And I think that's beautiful. And overall, I have a complete green lighthouse score with a overall better user experience. So for the last few slides, is a JavaScript site or JavaScript-driven site or stack really that bad? Not at all. I mean, I'm standing here in front of you wearing a JavaScript hat, but maybe we should focus as an industry in the future more on building sites that just work. And maybe we should worry less about the technology behind all the things that we build. If you want to have a look at the slides, they're available at my-links online, did-we lose direction. And I own the domain My Links Online, and I have to tell that to everybody. And I'm Stefan, I work for Contentful, and thank you everybody for listening.